Hey everybody, in this recording we are doing just really assorted right triangle trigonometry. It's basic, non-specific, I guess we could say. If there's an assortment here, we might see a Pythagorean triple, we might see basic Pythagorean theorem, we might see cases where we can scale down, we might see cases where we should scale down and all that good stuff. So let's go ahead and get started. So I'm going to start over here with this first example, and I see a 4 and a 6. These are not the members of any Pythagorean triple. So you basically should be doing Pythagorean theorem. However, we have a GCF. The GCF in the situation for these sides that we have is 2. So if I divide by the GCF, my 6 becomes a 3. My 4 becomes a 2. By doing the Pythagorean theorem with these numbers instead, you're going to make your life a little easier. You have smaller numbers to work with. So I'm going to go ahead and call this side x. So I'm going to go and do x squared plus 2 squared equals 3 squared. Here you have a 9. Here you have a 4. And you got x squared. Subtract the 4, x squared is 5. So x equals the square root of 5. Now, the question is asking for secant theta. Secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse. So that means secant will be the hypotenuse over the adjacent. From here, if that's theta, if you are wise, you will just use exclusively all of the scaled down numbers. You don't need to scale it back up. If you did scale this back up, the radical 5 would become 2 root 5, but you really don't need to do that. You can just use the scaled down numbers. So hypotenuse 3 over adjacent radical 5, multiply on top and bottom by radical 5, and you get 3 radical 5 over 5, and you're done. That is your answer. If you scaled it back up, you would get, like I said, 2 root 5 on that side. So you would have 6 over 2 root 5. Again, you can reduce by 2 and you get 3 over root 5, and you pick up from here. Or you don't reduce and you try to rationalize your denominator like this, and you mess up multiplying with the 2 root 5, you make a mess, I don't know. So I would just avoid it. And that's it. You're finished. That's your answer. That is what the secant of theta is equal to. Hopefully we're getting better. Maybe you should press pause. Try these on your own. Come back. I'll see you in a little bit. And maybe you're back. I hope you tried. Here I have 2 legs. So if I do Pythagorean theorem, I have root 43 squared plus 3 root 2 squared equals c squared, hypotenuse squared, whatever you want to call it. That's 43, guys. It's not whatever 43 times 43 is. The square root and the square are inverse operations of one another. Bye-bye. We just get the 43. Here, I talk about this in another video up ahead in the playlist a little bit. But 3 root 2, when you square it, it's with parentheses. This isn't our first rodeo. We're not in pre-algebra or algebra 1. You should be in pre-calculus. Maybe you're a geometry person watching this, I don't know. But you square the 3, 9, and you square the root 2. Squaring the square root of 2 gives you 2. And then 9 times 2 is 18. And you're going to add the 18 with the 43. 53, 63, take away 2, 61. So 61 equals c squared. So that means c equals radical 61. That's it. Sometimes you get gross numbers like that. That's okay. All right. From here, what are we looking for? Oh yeah, cosecant, reciprocal of sine. So it's hypotenuse over opposite. Root 61 over 3 root 2 multiply on top and bottom by root 2. A little squish, sorry. 61 times 2, that becomes 122. Radical 1, 2, 2 over root 2 times root 2 is 2. 2 times 3 is 6. A lot of people messing that up as well. So radical 122 over 6. And I don't think we could break it down more. It came from the 61 and the 2. I think 61 is prime. And you're finished. That's it. How about over here? We want to find tangent. Tangent will be opposite over adjacent. This is the opposite, the side that we don't have, that we want to find. Here's the adjacent. We already have that. So I know I'm going to have to rationalize my denominator in a little bit. So we're going to do some Pythagorean theorem. You could call it x. You know, maybe I call it y because it's vertical and it's going to be more like a y coordinate. So 2 root 15 squared plus y squared is 8 squared. 2 root 15 will be 4 times 15, which is 60, plus y squared is 64. Subtract the 60, y squared is 4, so y equals 2. So that side right there is 2. Ooh, I'm not on the page. So sorry. There you guys go. All right. So opposite 2 over adjacent 2 root 15. Oh, I just noticed something. 1 over root 15. And if you rationalize that, you get root 15 over 15. What did I notice? Silly me. I could have scaled it down from the beginning. I could have used root 15 divided by 2, right? Divide everybody by 2 and 4 instead. So if I did Pythagorean theorem with them, I would get what? Root 15 squared plus, I'm just going to call it m squared because it's a little different, equals 4 squared. Root 15 squared is 15 plus m squared is 16. Subtract subtract 15, m squared is 1, so m is 1. So I would have gotten 1, that's when I divided by 2. And if I did opposite over adjacent, I would get 1 over radical 15. Rewind, press pause, play it again, whatever part you're confused on. But I would have dealt with, do you see, smaller numbers. And a lot of you guys mess up squaring that. So it was avoidable in this one, okay? So this is just continuation. If I did it a different way, rewind, replay if you need to. How about over here? 72 and 78, do they have a GCF? Well, how far apart are they? They're 6 apart. Are they both divisible by 6? Well, 6 goes into 36 6 times, so 6 goes into 72 12 times. So if I divide by 6, I get 12. And since that's one more, that means, one more 6, that means if I divide by 6, I'll get 13. So what does that tell me? 5, 12, 13. Could I scale the 5 back up and make this side 30? I could, but you don't really need to. We need cotangent. That's going to be adjacent over opposite. Here's theta. Adjacent over opposite. 12 over 5. And that's it. You're done. You don't need to ever do Pythagorean theorem with this 72 and 78. Don't be silly. And here's just a medley of examples. It's a few concepts, guys. It's just, what are the 6 trig ratios? How do you simplify a radical? How do you square something like 2 root 3? How do you rationalize the denominator? What are the 10 Pythagorean triples? Do you know your special right triangles? I'll have a thumbnail to the formulas for special right triangles at the end of a couple of the videos in this playlist. Hope those examples helped. It's really that simple. They could be set up with a picture already, or it could be set up as a situation where you draw a picture yourself. It's all the same thing. It's really all the same thing. Okay? So if you leave a comment in any of the videos on this set of, like, I think I did like 5 videos so far, if you leave a comment in any of them specifying like a kind of example you want to see within the next, I don't know, 18 hours, I can make something. If you have a specific example you want me to do or a situation, whatever, just type it in the comment of one of those videos and I'll do my best to make a video on that. Also would like to figure out how to live stream, so I don't know how. Okay, hope that was helpful. Thumbs up or thumbs down. You tell me, communicate. And I'll see what else I could come up with to add, but that is the majority of stuff. I might be able to do one or two more for people to look at. Yeah, I could think of one or two more. But I'll get those up as soon as I can. All right. Have a great day. Bye.